All right. So again, the section that we're working on is section 27 in your Springboard book. What we are talking about today is the equation of a circle. Now, before we do that, we need to go back and talk about how do you define a circle. So can somebody tell me how you define a circle? Yeah, we've defined it twice now. This will be the third time we define it. Can somebody tell me how we define a circle? No one has a definition of a circle for me? Huh? It's not a line. All right, I'll start off. The set of all points. All right, the set of all points equal distance from a given point. And that given point is the center point, right? Now, there's a couple key words in there. All right, distance probably being the most key word. All right, because what we are going to be doing in here is we're going to be graphing a circle based off of the distance all the points are from a given point. We know that that given point, again, is the center of our circle. That distance is what in the circle?
The radius.
The radius, yeah. So the radius is that given distance from a center to any point on the circle. So our equation of a circle is going to be based off of the center point, the radius, and the thing that ties them together is the distance that's between them, between the points on the circle and that center point. So we're actually using the distance formula. Do you guys remember your distance formula?
Yes.
Right.
It's like square root and then like r.
So before we even get to the equation of a circle, we're going backwards for a second. D equals the square root of x2 minus x1 squared
plus 2 minus y1 squared,
yeah, good. That's our distance formula. All right. We are using that formula, and actually this is our equation for a circle. We just have to replace some of the values here. In the circle, our distance would be the same as our what? The distance will be our radius. The x1 value and y1 values, that's going to be the center of the circle. Now, so we're going to replace these values with the radius and the center. Now, when we talk about the center, we actually have a specific values. Instead of using x and y, we actually switch these out, and we use these other values in a couple different equations, h and k. And you guys have probably seen h and k before, because when you do the vertex form of a parabola, you use h and k. A lot of different graphs that have vertices use h and k as the vertex. In the circle formula, you use h and k as the center of the circle. As soon as I finish them. I'm only a third of the way through. Thought I was going to get further. But I got one version of the test graded. There's 3 versions. So cool. I got to do 2 and 3 still. All right. On here. So this is, again, our distance formula. Now, we're replacing these values with what we just said here. So instead of distance, we're going to be doing the radius. Now, when you do an equation, we don't plug in for both x and y values here. Because anytime you do an equation for any type of graph, you always have an x and y value, right? If you think about something like slope-intercept form, y equals mx plus b. When you have the equation, you actually only plug in for m and b. You don't plug in for x and y. X and y represent all the points there on a line. Same here. This x2 and y2, we're just going to leave as x and y, and it's going to represent all the points that are on the circle. So we're still going to have an x, but then x1 is being replaced with h, and y2, again, we're just going to leave that as y, representing all the y values on the circle, minus the y1 value is being replaced with k, and now this works as an equation for a circle. However, it's not the normal format that you see it in. All right? So normally instead of this format, they do change one thing. And it's kind of like Pythagorean theorem, because you remember how I said earlier at the beginning of the year that distance formula and Pythagorean theorem, same thing, right? Well, same thing here. Instead of leaving it like this, Pythagorean theorem doesn't have a square root in it, right? Same thing with the circle formula. You usually don't see the square root. They usually get rid of the square root. So if we were to get rid of the square root, what would happen to this equation? Say that again? R would be squared. So I'm going to write this really big down here. This is our equation of a circle that you need to memorize. R squared equals x minus h squared plus y minus k squared. Again, in this format, again, this is our equation of a circle. Equation of a circle. And in this format, you want to remember that R represents your radius, and the h and k value represent your center point. Yep, h is the x value, k is the y value. So again, this is what's really important. This is what our whole lesson today is based on, is that formula right there. Now, there are other formulas that you need to be familiar with, because we're talking about graphing. So we talked about distance formula at the very beginning. In this format, again, we will still use distance formula, or again, you could even use this version of it if you want to. And there's one other formula that's going to come in really handy today as well. What other formula do we usually always talk about when we talk about distance formula? Another formula that we always seem to go over anytime we cover distance. Midpoint, yeah. So if you don't remember midpoint, you might want to write that somewhere on your paper as well. In order to find the midpoint, so I'm going to write it over here, midpoint, just so you have it somewhere on your paper. That's the average of your x's and average of your y's. So that's where you do x1 plus x2 divided by 2, and y1 plus y2 divided by 2. It does come in handy. Now, how does that help you when it comes to a circle? Well, if you aren't given the center of a circle, the midpoint formula can help you find the center of a circle. What would you have to be given if you didn't have the midpoint, but you're asked to find you're asked to find the center? Diameter, yeah. So there's too much glare there. So yes, diameter. If you were given a diameter and you were able to identify the two endpoints of the diameter, midpoint formula would help you find the center of the circle. So again, that's where midpoint comes in. But again, we're going to be using our equation for a circle. We'll be using our distance formula. We'll be using our midpoint formula. So for today's notes, we can stop there. Now, if you want to save this paper and add to this tomorrow, we have quite a few more notes that we're going to add to this probably tomorrow, because we're going to get even more into algebra again. You guys remember when you had like perfect square trinomials, completing the square? Yeah. Now, I will say this. When you did completing the square before, we talked about factoring. I will talk about it in terms where we don't have to factor, all right? But we still have to use completing the square. So again, that'll be for tomorrow. Today, this is all you really need to know in order to complete the questions that we're going to talk about during class and the homework for tonight. All right. So let's go over to your Springboard book. We're going to go to page 395. 395. Again, keep your notes handy because you probably want to reference them.
Yeah, I have no shoes.
So, this is page 395. Now, I'm not going to do every single question on here, but I'm going to do quite a few of them with you. Yes. It passes up there on the wall. Yes. All right. So, at number 10, let's start there. It says, explain how to use absolute value to determine the radius of a circle centered at the origin, given a point on the x-axis. Well, that seems kind of an odd question. But let's think about why we're talking about absolute value. What are we dealing with? What's the main idea behind this formula? Distance. And distance is always what? It's always positive. So absolute value always gives you a positive number, right? So on here, in order to determine what the radius is a distance. And it always has to be a positive distance. So let's take a look at what this is referring to. Now, I'm just going to draw a random circle up here just as a reference. So here is my x and y axis. If the center of my circle was at the origin, and I drew a circle around that point, so it looks something like that, we have two different points that fall on the x-axis, right? We have this point over here, and we have this point over here. How could we use either one of those points to determine our radius? Okay, you could use distance for it, but now go back to the question. The question asked us specifically, how do we use absolute value to determine the radius in this specific scenario? Yes?
If the center of a circle is on the origin, then whatever value the x is, that's going to be your radius.
Yes.
That's how long it is.
Did anybody hear that? So again, if the circle is centered at the origin, whatever the x value is, or really whatever the y value is at these points as well, would also work. That would end up giving you your radius. But now your radius can't be a negative number. So it's the absolute value of your x at the points where it crosses the x-axis, or you could say even it's the absolute value of the y's where it crosses the y-axis. Again, that only works if it's centered at the origin. All right? So, absolute value of x value at x axis. Something along those lines. All right. Now, for number 11, it says write the equation of the circle described. So we're not starting off with easy questions here. All right, there's some easier questions down below in the practice, and we'll get to some easy questions. But some of these questions make you think. All right, we're going to take a look at parts A and B. All right, so for A, it says we have a center at 3, 6. I just sent somebody when they come back. I think it was AJ. Yeah. So the center is at 3, 6. And it passes through the point 0, -2. So we have a center point. What else do we need in order to write our equation? So you need two things. You need the center and you need the radius. How do you find the radius? So we're given a center and a point on the circle. How would you find your radius? So we can use our distance formula. And going back to this, again, every time I do my distance formula for this, I'll use it in this format because, again, it's the same thing. We're just plugging in the center point and another point on the circle. So, on here, or again, you could even use the equation of the circle formula if you want to. So, I'm going to plug in, we have R equals the square root of, and then we had a point on the circle is 0, negative 2, so 0 minus 3 squared plus negative 2 minus 6 squared. Right? So let's figure out what this radius is. We have R squared, and we'll do a square root. All right, 0 minus 3 is negative 3. Negative 3 squared is 9. Plus negative 2 minus 6, negative 8. Negative 8 squared, 64. Again, your values at this point should always be positive. 9 and 64 add up to 72. Wait, 73.
Yeah.
Sorry, I thought I heard you say 72. You said 73?
I haven't heard of my paper.
Sorry. So did you say the wrong?
I did say the wrong thing.
Okay. All right.
Bad.
So 73. Now, do you know what the square root is of 73? No, I don't know either. Do we need to know? No. Why don't we need to know the radius? It doesn't matter. So I just said a second ago we need the radius in order to plug in. But do we really? What do we have to have in order to plug into our equation of a circle? So the center point and the radius squared. Which, the radius squared in this case, if we were to square this, would just be 73. So you don't actually have to figure out what the exact radius is in this case. All we want is the equation of the circle. So although normally it would be good to know the center point and the radius so that you could plug into your formula, since we're trying to find the value to plug in for the radius, we don't actually have to get the exact radius, especially since it's not going to give us an exact value. We can leave it as the radius squared, because now we can just plug that into our formula. So going back to our formula, this would be R squared, so 73, equal to, parentheses, x minus 3 squared plus y minus 6 squared. So we had our R squared value, we had our h value, we had our k value, and that's it. That's our equation. So one thing that I see a lot when it comes time for test and quiz on this section is a lot of extra work that's not necessary. You don't have to spend a lot of time solving for R unless it specifically asks for what is the radius. If it's asking for the equation of a circle, don't get wrapped up in trying to simplify R, finding the exact value of R, simplifying a radical. You don't have to do all that. Again, you're going to put it as the R squared value anyway. The only time you're going to have to simplify a radical is if they specifically ask you for the R. What is the radius? All right. Otherwise, it's always going to be R squared. All right. Let's do one more from that part. So B. Again, also not the easiest problem. All right. It actually got a little more challenging here because now they said we have the diameter with endpoints, and they gave us the two endpoints of the diameter. So first, we don't have the center point, and we don't have the radius. The two things that we need. So what's the first thing that we can do, though? We can find the midpoint, because if you find the midpoint, you find the center. So first thing we're going to do for number 11 here, let me put a sticky note over this so I can try the same spot. So for 11B, we're going to have the midpoint formula, which, again, we went over a second ago. I'm going to write it out so that if you forgot what it was. So again, HK in this case would be our midpoint. So we're using our midpoint formula. X1 plus X2 divided by 2. Y1 plus Y2 divided by 2. Again, this is only true if x1 and y1 are the ends of the diameter, right? So that's what's happening in this problem. That's why we can use the midpoint formula to find h and k. So in this case, we had 2 plus negative 10 divided by 2. And we had 5 and 7 divided by 2. And average of the x's, average of the y's. 2 plus negative 10 is negative 8. 7 and 5, that's 12. So our x value here is going to be negative 4, and our y value would be 6. So now, we have our center point. So now we can find the radius. And you have one of two options here. You could either take the values that you have there, find the distance between them, and divide by 2. Or, now that we found the midpoint, we can take that midpoint, which is our center of the circle, and use either one of those other 2 points to find our radius. Or really, again, we really only have to find the radius squared. So if you want to use the formula in the format of the equation of a circle, you can do it in that format. So we have r squared equals, and plugging these values in, I'm going to use the 2 and the 5. So 2 minus negative 4 squared plus 5 minus 6 squared. Again, the 2 and the 5, that was one of the points. The negative 4 and the 6, that was the center point. So now, 2 minus negative 4. Well, that's the same thing as saying 2 plus 4. So that's what? 6. And 6 squared is 36. 5 minus 6 is negative 1. Negative 1 squared is 1. 36 plus 1 is 37. So now, we know what the radius squared is, right? This is r squared. We know what our h and k value is. Those are the 2 things we need. We just have to plug it into our formula. 37 is equal to x minus, well now, if I plug in negative 4, that actually makes this what? Plus 4. So keep in mind, as you plug into this formula, there's a negative in front of the h and k. So it's always going to reverse. For the y value, so you plug in the 6 for your k. So you have y minus 6 squared. And that would be our equation. Any questions so far? Again, we didn't start off with the easiest questions, but now hopefully some of these that are coming up will seem really, really easy. All right. So let me move that down. So, all right. So let's go down to 12. Now, on 12, it says write the equation of a circle centered at the origin when given the radius. So you're given a radius of 6, right? So we're going to plug this into our formula. If I take 6 and plug it into my formula for a circle, first thing I'm going to write is what? So I write 6? 6 squared, which is 36. Now, it's going to be equal to x minus what? 0 squared plus y minus 0. Why did you put zeros in there? So at the origin. Again, the origin is 0, 0. Now, should I leave my equation looking like that? No. So if it's centered at the origin, do I really need to have minus 0? No. So my final equation for A here will be 36 equals x squared plus y squared. Kind of ends up looking more like Pythagorean theorem almost. So again, if it's centered at the origin, you won't have an h and a k value because it's 0. So now that you've seen that one, take a minute and see if you can do B on your own. So see if you can write a correct equation for B. Oh, Ashley. I think over there, I'm not printing that saying on my desk. I think that's your stuff. I'm not positive.
Probably.
It was back here where you sometimes leave your markers and stuff. Yeah, it was saying behind your desk, so I figured it had to be yours. Sorry. I will. All right. What do you guys think for your equation here? So we had, guys, there's lots of little talking. I can't hear if anybody's actually trying to answer me here. That's it. 12 equals x squared plus y squared. And that's it. That's your equation. Okay. 13. 13, A and B, they're pretty easy. You don't have to find anything. They give you all the values you need. You have a center point. You have your radius. All you got to do is plug them in. So on the next one there, we have the center is at 7.2. The radius is at 5. Now, the couple things you need to remember as you're plugging these in, the R value gets squared. The center point values, as you plug them in, it's really the opposite sign because there's a negative in front of them. So what's our equation going to look like for 13A?
25 equals x minus 7 squared plus y minus 2 squared.
Perfect. Whoops, you said minus and I wrote plus. Let me fix that. Sorry. She said it so fast I couldn't keep up. There we go. So 25 equals x minus 7 squared plus y minus 2 squared. Again, as you plug that in, the values, the signs in front of these two center points are both minus signs because that's what it is in the original equation. All right. Somebody else want to give me 13B? 81. Okay, let's start there. Oh, he started it. Hold on. 81 equals, go ahead. X plus 4 squared. Perfect. So both of those were negatives. So when we plugged them in, they both became positives. So again, we had to square the radius and make sure we plug those values in correctly. And that's it. That's all we have to do for those. Now, 14 is the exact opposite of what we did on 13. 14, we actually have to look at the equation and identify what is our radius, what is our center point. So, on 14, what is the center of that circle? 5, 0. Again, we put out a 5 because it's the opposite of that, and a 0 because the y is by itself. What's the radius?
15, sorry.
15. Again, knowing your perfect squares helps you there, right? That's a perfect square. That square rooted is 15. All right. For 14B, can I get somebody else to give me the center and the radius there? What you got? -4 and 2, yeah. All right. So center is at -4, +2. And the radius? Square root of 13. Yeah. So you got to square root the 13 because, again, that's r squared. So you have to take the square root. Can you take the square root of 13? No. Can you simplify it? No. So it's just going to stay square root of 13, and that's an acceptable answer. All right? Again, that's an exact value. Any questions so far? All right. That's as much as I want to do with you guys today. So your homework tonight is page 399, 1 through 9. Now, again, some of them are going to be more challenging than others. Some of them are going to make you think. I purposely avoided a couple examples that are similar to some of those questions. So, again, try them out. Again, there's 9 of them. Some of them are easy and straightforward. Others are not. But again, try those 9 questions. All right? And tomorrow we'll get into completing the square and doing all that stuff. So